symposium. Dr. Ryan Falk is a research associate in the School of Biomedical Engineering at the University of British Columbia. His research examines how physical activity, sedentary behavior, and sleep impact the physical and cognitive health of older adults at risk for functional decline. He has authored more than 80 papers, and each index is 26, according to Google Scholar. Okay, please start your presentation.
Thank you, Dr.
Yes.
And thank you to all of you for attending. I know it's relatively late, so I appreciate you all being here at the end of the day. In terms of what we'll be talking about here today, first I'd just like to acknowledge some of the members of the laboratories that I work with. So first, my former PhD supervisor, Dr. Teresa Ambrose, who I still collaborate with quite closely at University of British Columbia. And then also my current supervisor in the School of Biomedical Engineering, Dr. Roger Tam. And then also all the folks that I've collaborated with over the years, the lab staff who've helped with a lot of the projects that I'll be talking about here today. And then also some of the students who've also been instrumental in being able to accomplish these projects. So before I get going, I'd just like to share a little bit about University of British Columbia with you. So one of the main factors at University of British Columbia that we have that's a real benefit for us in terms of looking at exercise and its impacts on aging and healthy aging in particular is that we work out of the center called the Center for Aging Smart, for Solutions for Mobility, Activity, Rehabilitation, and Technology. And this is a really unique center that I have the opportunity to be able to work at. We have a number of different facilities within the center, including an open MRI machine. You can see it here in the middle, being staffed by one of our research staff. And then we also have a full exercise prescription suite. We have a number of different tools for looking at physical activity, sedentary behavior, as well as sleep. Now we do things like frontal EEG, we have FNIRs, we have MRIs, but we have a 3T MRI that's located at University of British Columbia. So we really do have an incredible facility to be able to do research. So if you ever are in Vancouver, then I would strongly suggest that you come visit our facility. I think you would all find it quite interesting. So with that being said, I'd just like to also share some disclosures that I have. So I am funded through the Canadian Institutes of Health Research and also the Michael Smith Health Research BC Postdoctoral Fellowship. And then lastly, as is customary here in British Columbia, we do a land acknowledgement, since most of the land that we work on is actually still the land of the ancestral people in the area, specifically the Musqueam, Squamish, and the Slater Nations, who we have access to the land through a lease operation. So we're very grateful to be able to conduct research on those lands. Okay, so in terms of what I'll be sharing with you here today, there's a couple of different things. First, I'd like to just give you a broad overview of my research in terms of what I work on. Then I'd like to share with you some of the highlights of those research. And then lastly, I'm going to address one research gap in particular that is currently ongoing and that Dr. Kong and I are currently working on together, which is why I'm here in China right now. Okay, so in terms of the overview for my research, broadly, as I think most of us are aware, is there's an increasing number of older adults worldwide. And this is something that has been going, that has been happening quite exponentially, at least in Canada. People just aren't having as many children right now, which is increasing the number of older adults in particular. And this is causing some particular concerns when it comes to aging, because aging is associated with certain things that we have to be aware of. So specifically, one thing that I'm sure most of us can agree on is that as we age, we see declines or changes in our physical and our cognitive health. And while that's a normal part of the aging process, we can all expect to see some declines in terms of our physical function and our cognitive function. Some individuals are going to be experiencing greater cognitive decline and physical decline than expected for their age so with this in mind, one thing that I'm really interested in is looking at the differences between these two trajectories, the differences between individuals who experience healthy aging and those who experience a functional decline in terms of their aging processes. Now, one thing that I would mention as well is that individuals who do experience functional limitations, there's about 2 million in Canada right now, and that this costs roughly about $100 billion worldwide. So if you can imagine, as more and more older adults are going to be around as the population continues to age, this is just going to exponentiate the economic costs of people living with functional decline. So one thing that does help with that is lifestyle factors, which is what I'd like to share with you about here today. And we think that this is one possibility that we could help to change the trajectory in terms of decline for these individuals. So 3 lifestyle factors that I'm really interested in are physical activity, sedentary behavior, and sleep, and how they can relate to our physical and our cognitive health. Now, there's a number of different ways that we can refer to physical activity, sedentary behavior, and sleep as a collective unit. For right now, I'm just going to refer to this as the 24-hour day. There's other ways that we refer to this, such as 24-hour movement behaviors, 24-hour physical behaviors, activity behaviors, and so on and so forth. For right now, we're just going to focus on just calling it the 24-hour day, but we'll talk a little bit more about that terminology later on tonight. So it's important to note that each of these behaviors have different energy expenditures, meaning that they have different amount of energy that you expend while you engage in them. They can also be classified as wake-based behavior, so a behavior you do while you're awake, or a behavior that can be done while we're sleeping. But they're also independent, meaning that when you perform one behavior, that also means that you can't engage in the other two. And what we see is that if there's an increase in terms of the amount of time that we spend being physically active, that means that there has to be a decrease in the amount of time that we spend in sedentary behavior or in sleep. So let's talk a little bit more about what those behaviors represent in terms of, and what the definitions are of that. So broadly, physical activity refers to any bodily movement that increases our energy expenditure above resting or basal levels. There are 4 broad domains of physical activity, specifically household, so that can be things like doing chores, doing the laundry, vacuuming, making food, things of that nature. It can also be occupational, so depending on what kind of work you do, you can have more occupational activity. So the construction worker likely has more activity than us academics. That would probably be a pretty consistent thing that we see across the board. Transportational activity, so the activity that you do to get to and from the place. So if you walked here to the seminar tonight, that means that you engaged in transportational physical activity. And then last being leisure time physical activity, that is physical activity we do for leisure purposes. And this could include things like exercise, which is a subcategory of physical activity, which refers broadly to planned or structured physical activity for the purposes of trying to increase or maintain our physical fitness. We can also classify physical activity based on its intensity, so either as light physical activity or as moderate to vigorous physical activity. Light physical activity is physical activity done between 1.5 and 2.9 metabolic equivalents, and then moderate to vigorous physical activity is anything that's above 3.0 metabolic equivalents. Okay, now there's another thing that we can think of as well, and this is standing behavior, which is a little bit more difficult to be able to encompass within this definition of physical activity. Some people say it's a separate behavior, some people say that it's just a part of physical activity as well. But broadly, standing behavior is just what I'm doing right now, standing. So there are 2 separate types, there are some differences in terms of the types of standing behavior that somebody can engage in. Active standing behavior would be more intense standing behavior, so if you can think about things that would be like that, it might be weightlifting would be a good example of standing behavior that could be considered active standing behavior. But there's also passive standing behavior. So for instance, if I were just to sit here and play on my phone and not move, that's probably more passive standing behavior. And right now I'm engaging in more passive standing behavior, probably. Then there's active sitting, which is another type of light physical activity. So that can be when your physical activity level is above 1.5 metabolic equivalents. In terms of sedentary behavior, broadly the definition for this is a weight-based behavior that's done from the seated or lying position that engages less than 1.5 metabolic equivalents. So this includes a number of different activities, but the ones that we classically think about are things like television time and computer use, which are often thought of as being our screen time. So we usually think of those two being conceptualized together. But we all can agree that sedentary behavior is another different behavior as well that encompasses that 24-hour day. Sleep is a little bit more difficult to be able to define. So there's several different definitions for sleep. However, for today's purposes, we're going to refer to sleep as a rapidly transitional neurobehavioral state that is typically seen in humans as encompassing postural quiescence, closed eyes, and the ability to rapidly change out of that behavior into a wakeful state. So there's a couple different aspects of sleep that are important to think about. We have sleep health being one definition for the things that are important for sleep, and then we also have sleep quality. For today's purposes, though, the real things that we think about that we can agree on for both of these definitions that are important are sleep duration and sleep efficiency. And these are really what a lot of researchers are really looking at in particular, especially within the space of, within the health space. They're very interested in sleep duration and sleep efficiency. Sleep duration is the amount of time that you spend sleeping. Sleep efficiency is the total amount of time that you spend sleeping as a proportion of the amount of time that you spend in bed trying to sleep. So if you have higher sleep efficiency, that means that you had a better sleep quality. Okay? Now there's one more aspect of sleep that's a little bit, makes it a more complicated behavior, and that's the fact that it's also controlled by circadian rhythms. So broadly speaking, there are two different biological processes that control our sleep. The first one is called the homeostatic process, which is also referred to as process S. That is basically just the underlying biological drive that makes you fall asleep after you've been staying up for longer and longer. So if you've ever pulled an all-night study session for an exam, then you would note that as time goes on, you're going to get more sleepy, and you're going to want to sleep, and you have to fight that urge. That is that process S. Then there's the second process. The second process is process C, which is a circadian process, which overall is what we would refer to as the 24-hour biological clock, which helps to regulate our sleep-wake cycle and our solar light-dark cycle. This process is what causes you, after pulling that all-nighter, to be able to stay awake during the day, because it's what it is allowing you to be able to stay awake in terms of that solar light-dark cycle. These two things have to align in order for us to have good sleep. Okay? Okay, so to get more into my research themes, broadly there's three themes that guide my research. The first one is looking at the effects, both individually and combined, of these different behaviors on healthy physical and cognitive aging. So this can include things like exercise and how that can affect physical and cognitive aging, but also physical activity promotion. It can include studies looking at how decreases in sedentary behavior can improve our cognitive health, and then also how changes in sleep might also promote better cognitive health or physical health as well. The next theme is trying to understand how combinations of these different behaviors might be able to impact health. So if we were to manipulate both our sleep and our physical activity levels, can that improve our physical and our cognitive function? And then next, I'm interested in trying to understand these interactions and how these interactive relationships work. Since these behaviors are related to each other through that 24-hour cycle, then what I'm very interested in is how the interactions of these behaviors can help to promote physical and cognitive health. And then lastly, the third theme is trying to understand the modifiable and non-modifiable mediators and moderators of the relationships of these behaviors with physical and cognitive health. So when I say something that is non-modifiable, I'm referring to things like biological sex or age, things that we can't change. When I talk about something that is modifiable includes things like socioeconomic factors, green space, blue space, and things of that nature. And then also, I'm interested in different clinical populations. So the clinical populations that I work with quite a bit are individuals with mild cognitive impairment, which is sort of a precursor to dementia, and then also people with chronic stroke. So in terms of my approach, it's a combination of both observational and experimental studies. When I talk about things that are observational, these are large longitudinal studies. So in Canada, we have something called the Canadian Longitudinal Study on Aging, which is one study that I work with quite a bit. The other study being the UK Biobank that I work with quite a bit as well. And these studies are beneficial for promoting better public health policy. They can help with improving our diagnostic capacity, so our ability to be able to clinically understand the underlying causes of disease and perform better tests for those diseases. And then I'm also interested in understanding the experimental impacts of these diseases. And this is through things like randomized control trials. So, and these can be something that can help to improve clinical guidelines and also to improve better evidence-based practice. And just like I mentioned before, I've worked with a number of different clinical populations. My focus is on clinical populations, and these are just some of the different populations that I work with. So it kind of runs the gamut. So in terms of some research highlights, I'd just like to share with you 3 separate examples of my research and how these themes tie together as well. So for the first example, I'd like to share with you the results of a randomized control trial that was looking at the effects of whether we can improve sleep using something called chronotherapy in people with mild cognitive impairment. And I'll explain what chronotherapy is in just a minute. So, as some of you may be aware, as we get older, our sleep changes. And while this is a normal part of aging, we do know as well that older adults who experience poor sleep have a greater risk for getting mild cognitive impairment and also dementia. But one thing that also happens as well is that as we start aging, and if we have mild cognitive impairment, that actually increases our risk for sleep disturbances. In turn, what we also can know from the science is that if you experience those increases in sleep disturbances, there's a greater risk for transitioning from mild cognitive impairment into dementia. So this is sort of a vicious cycle that happens where somebody gets worse sleep, they start to have worse cognition, and then that in turn leads to even worse sleep, and so on and so forth. And this can lead to dementia over time. So one thing that we might be able to do to be able to help people is something called chronotherapy. So you may be asking yourself what chronotherapy is. Broadly, what chronotherapy is it's a set of external time cues that can help to regulate our circadian rhythms. So this can include things like bright light, so bright light therapy, light at specific times of the day, which can help to change our biological clock. It also can include things like exercise at specific times of the day, which can help to regulate our internal clock time as well. And this is done through something called entrainment of the biological clock. So for this study, what we were interested in trying to understand is whether chronotherapy was something that we could actually use to improve sleep in individuals with mild cognitive impairment. So for the study, we had individuals between 65 and 85 years of age with probable mild cognitive impairment, and then also poor sleep using a questionnaire called the Pittsburgh Sleep Quality Index. All participants at baseline underwent objective sleep quality using something called the Emotion Lunch 8, which was a wrist-worn actigraph that's worn on the non-dominant wrist for a period of at least 7 days. We also measured subjective sleep quality using something called the Pittsburgh Sleep Quality Index. And we measured cognition using something called the Alzheimer's Disease Assessment Scale Plus. The Alzheimer's Disease Assessment Scale Plus is a combination of the original Alzheimer's Disease Assessment Scale with several different executive measures in order to provide us with a more global measure of somebody's cognition. Next, we randomized individuals into one of 2 groups. We had the personalized chronotherapy group and then also the usual care control group. During the first 4 weeks of the intervention, the personalized chronotherapy group received once weekly sleep hygiene education sessions. These sessions entailed a number of different things, but we educated them on ways to have a regular bedtime, avoiding bright light late at night, trying to find ways to help improve their sleep that could sort of be seen as a pattern to try to help improve their patterns around bedtime. So it's about building better bedtime routines primarily. During that time, we also gave the usual care control group optional weekly health enrichment lectures. These lectures didn't really cover anything to do with sleep. They didn't talk about exercise or anything like that. We focused primarily on things like diet, stress, and things of that nature. There was meditation and things of that nature. So it was still active in some way, but it wasn't something that was going to be directly related to our original intervention itself. During the next 20 weeks of the intervention, the personalized chronotherapy group received individually timed bright light therapy, or they received individually, and they also received individually tailored physical activity. I'm happy to share with you after this is done the details of this program, but broadly speaking, these things were individually tailored based on somebody's bedtime, when they woke up, when they went to sleep, and then also based on how much activity they were getting at baseline as well. So there was a little bit of individual approach to everybody's plan in terms of their activity promotion, and then also the bright light therapy as well. During that same time, the usual care control group, they received no intervention, but we did call them once every 2 weeks to just ask them about their general health and well-being. I should also mention that the personalized chronotherapy group received a Fitbit as part of the physical activity promotion plan. So that was part of it, was getting a Fitbit and then also being counseled to help improve their physical activity using something called the brief action planning approach. We then measured individuals both in terms of their sleep and their cognition at 12 weeks and then 24 weeks follow-up. So in terms of the results, what we found was that there was no effect on our primary outcome of sleep efficiency. However, interestingly enough, we did find that there was an effect in terms of sleep quality at 24 weeks follow-up, which was our primary endpoint. Specifically, what we saw was that the intervention group had a 1.5 point better sleep quality index score than the control group, suggesting that that group actually had better sleep at 24 weeks than the control group. However, there was no effect of the intervention in terms of cognitive performance either. So what does this mean? Well, it seems to suggest that while we may not be able to improve circadian regulation, or it's at least unclear whether we can improve circadian regulation using this approach, it does look like we can improve some aspects of sleep quality using this multi-step tailored approach. However, it's also not clear whether this type of intervention can improve cognitive function as well. So for the second study I'd like to share with you, this is looking at whether there are differences in terms of sleep between individuals with and without chronic stroke. For this study, as I'm sure we're also aware, if we have stroke can lead to increased risk of obstructive sleep apnea. It can also lead to sleep-wake disorders, insomnia, and things of that nature. So there's a number of different things that can happen after we have a stroke in terms of changes in our sleep. But what's interesting is we also see that there could be some reverse causality. So if you have obstructive sleep apnea, sleep-wake disorders, or insomnia, you might actually have a greater risk of having a stroke as well. Now, one thing that's interesting though is if you have a stroke and then you present any of these issues of obstructive sleep apnea, sleep-wake disorders, or insomnia, that can also lead to a greater risk of having a second catastrophic stroke. So at the very least, what we do know is that sleep is very, very important in terms of health for individuals with chronic stroke. But one thing that's not really clear is how sleep and cognition are related in individuals with chronic stroke. So we were really interested in trying to capture not only somebody's sleep and its impact on cognitive health, but also differences between individuals with and without chronic stroke. So for this study, we performed something called a randomized cross-sectional study, a comparative study, wherein we took two separate populations from two separate studies. One, a population of individuals that that were healthy and didn't have a stroke previously, and then we had a separate population of individuals who had previously had a stroke. We looked at these individuals and we age and sex matched them, so they had the same age and the same sex with whoever was compared to them in that stroke, in that study, leaving us with a sample of about 35 individuals that were age and sex matched in the study. So if you can think of it this way, is we're trying to make this as
comparative as possible between the two populations. Now, what's interesting is we found several different things that were of interest. First, unsurprisingly, individuals who previously had a stroke had worse cognitive performance than individuals who had not previously had a stroke. That's not really that surprising. We know that if you have a stroke, that leads to, generally speaking, declines in your physical and your cognitive functions. So that may not be surprising, but what's interesting is we did find that there were differences in terms of sleep between individuals with and without stroke. So what we found was that individuals who previously had a stroke had way more fragmented sleep. What fragmentation refers to is how restless you are, how much you move around while you're sleeping. But what's also interesting as well is that individuals who previously had a stroke, they also had longer sleep than individuals who had not had a stroke. So this is actually surprising because we would think that like an individual who had a stroke might actually have shorter sleep time, but it seems like it's actually the opposite. They have a much longer sleep pattern. What that might be is that might be part of the recovery process, we think. So potentially if you have an injury, you tend to sleep longer because it's something that's required for your body to heal. But what seems to be happening is not only do they need more sleep time, but their sleep's more fragmented. So they're sleeping longer, but it's not necessarily good sleep, if that makes sense. Okay, so we also saw that, interestingly enough, that there was sort of the same pattern as well between in terms of sleep duration. So for both subjective sleep duration and then also for objective sleep duration, both it appears that like the individuals with chronic stroke actually were reporting a longer sleep duration. So it was comparative in terms of what they were actually reporting to what we were actually getting when we had measured it objectively. So that's another interesting aspect of this. Secondly, what's interesting is we saw some interesting associations between sleep and cognition based on individuals with and without chronic stroke. So here on the left-hand side, what we can see is that for individuals who had worse sleep quality, then compared to individuals who had not had a stroke, individuals who had previously had a stroke, there was a greater discrepancy in terms of their cognitive performance. So meaning that, let's say you had really poor sleep fragmentation, you previously had a stroke, that means you tended to have much worse cognitive performance compared to your non-stroke peer, in comparison to somebody that had very low sleep fragmentation. So it seems like that sleep fragmentation was associated somehow with having a greater discrepancy in terms of your cognitive performance. In addition, we saw the same pattern as well for sleep efficiency. So individuals who had previously had a stroke and had poorer sleep efficiency, those individuals tended to have a greater discrepancy between their cognitive performance in comparison to their non-stroke peers who also had poor sleep efficiency. So there's two things that we can really say about this study. First, what it appears is that older adults with chronic stroke who have poor sleep also and cognition, older adults who have previously had a stroke, they have worse sleep and worse cognitive performance than their non-stroke peers. And next, what we can say is that poor sleep may also be an indicator of having increased risk of cognitive decline among individuals who with chronic stroke. Okay, so the final study that I'd like to share with you is something that's looking at the associations of multiple behaviors and their relationships with cognitive health. And I'm going to really focus here now on some MRI related outcomes. So we're going to focus on neuroimaging for these last two studies. So first I'd like to share with you a little bit about the study design. So for both of the studies I'm going to share with you right now, both of them are coming from a randomized controlled trial called the Monitor OA study. This was a study among older adults at least 50 years of age who had knee osteoarthritis and were involved in a study to try and increase their physical activity and reduce their sedentary behavior. So in terms of what we did is there was a baseline assessment wherein we provided demographic assessment, and then we also had participants wear the SenseWear Mini, which is a multimodal device that's capable of measuring physical activity, sedentary behavior, and sleep concurrently. And it's worn on the non-dominant tricep for a period of about 7 days, and it provides accurate assessments of all three of these behaviors. So next, we took a subsample of about 30 individuals who agreed to perform an MRI assessment. We performed 2 separate MRI scans. The first one being a 3T MRI structural scan. So we were looking at somebody's brain structure, specifically somebody's cortical thickness. The second thing we did was something called a task-based fMRI, where we were looking at the activation in terms of the brain during a specific cognitive task. In this case, the go, no-go executive task. And I'll explain what that is right now, just so it's clear. So the go, no-go task is composed of 2 separate cognitive tasks. The first task is the go task. It's very, very simple. Somebody's in the MRI machine, they're laying down in the MRI, there's a screen, like a TV screen that's in the MRI, and then they have a little remote control that they have that they place their hand on. And what we do is we show them 4 different letters that will appear on screen one after another in a random order. And basically what we ask them is every single time you see one of these letters, we want you to tap your finger on the remote control. So if you see an L, N, F, or K, every single time you see it, you tap your finger. This is just a simple reaction time test. It's not that hard, okay? But once we get done with this go task, we then have a second condition that we have people do. This is the no-go task. Now we ask them to still tap their finger every single time they see an L, N, F, or K, but we also ask them to now not tap their finger when they see an X. So they tap their finger when they see an L, they tap their finger when they see an N, all of a sudden an X appears on the screen and they have to hold back. And this can be quite hard if you can imagine, because now you're thinking about 2 separate things that you need to do at the same time. And so this is a great way of being able to measure somebody's executive function, which is a higher level cognitive process that is really important in terms of our planned behavior. It's something that we need to be able to do a lot of our higher level thinking. And so when we compare these two different tasks, and we look at the activation in the brain, it's a great way for us to be able to understand how somebody's brain is working when they're having to think about these higher level processes. Okay, so for this study, we were looking at 2 separate things. The first thing that we were really interested in was we were trying to understand what are the independent associations of physical activity and sedentary behavior with brain structure, specifically cortical thickness. The next study that we were looking at is we were interested in trying to understand how physical activity and sleep were associated with brain function excuse me, during an executive function task. Just give me 1 second. Okay, so for the first study, so there were some interesting things that we found. First, we saw that there was an association between greater amounts of physical activity and greater cortical thickness in 2 key areas of the brain, specifically in the superior frontal gyrus, and then the temporal pole, both of which are pictured in red over here. Both of these areas are closely associated with Alzheimer's disease, and they're also closely associated with cognitive decline as we get older. So if you can think of it this way, is being more physically active as we age might be neuroprotective for somebody's brain health, specifically their brain structure. What's also interesting about this is that we saw that this was independent of the amount of time somebody spent sedentary. So if you were more sedentary, it didn't really matter how sedentary you were, just as long as you were being more physically active. Interestingly, though, we didn't see any association between sedentary behavior and brain cortical thickness independent of the amount of time that was spent physically active. So what that means is that sedentary behavior doesn't really have the same relationship with brain structure after we account for physical activity. So one other thing that we also saw is that when we looked at the associations of physical activity and sleep with that brain function task, we saw several different things of interest. So first, in terms of looking at the independent associations of physical activity with brain activation during the task, we saw that greater physical activity was associated with greater activation in an area of the brain called the anterior cingulate cortex. The anterior cingulate cortex is an area of the brain that's closely associated with executive function. So it's something that we use and is activated whenever we're doing any higher level cognitive processes. What we also saw is that higher amounts of sleep duration were associated with more activation in an area of the brain called precuneus, also closely associated with executive function as well, although it's in a different sort of pathway, if that makes any sense. So what this seems to suggest is that physical activity and sleep might be associated with executive performance through different mechanisms, if that makes sense. So broadly, to summarize the results of this study, there are two separate things that we can say. First, physical activity seems to help ameliorate the negative consequences of too much sedentary time. So being more physically active is better regardless of how much time you're actually spending being sedentary. Next, what we can also say is that the amount of that physical activity and sleep are both associated with better brain function, but it seems to be that they're doing so through different pathways. So it's not really clear how they're necessarily, if they're doing it synergistically or not, or whether it's just two separate pathways working at the same time. Okay, so lastly, I'd like to share with you just some of the research gaps that I've identified within my own work, and just kind of share with you how I see moving forward with this. So as I've shared with you throughout this talk, I use a number of different ways to look at how these three behaviors can impact our physical and cognitive health as we get older. It's through a combination of both observational and experimental designs. But another way that you can look at it is there's three broad program goals that I have. So the first one is sort of like a higher level goal. It's a 30,000 foot goal, if you will. That is basically trying to address the current challenges in 24-hour research, specifically as it regards to aging. Next, I'm also interested as a sort of more granular goal, is trying to understand whether we can target these lifestyle behaviors through approaches which are going to help to promote better aging and prevent functional decline. And then lastly, I'm interested in trying to understand how social determinants of health, things like socioeconomic status, things of that nature, intersect with this 24-hour lifestyle approaches, and whether they can help to promote healthy aging. So I don't have time to share with you all the different ways that I'm addressing this, but what I'd like to share with you in particular is one thing that brought me to China and that I'm working on right now. And this is a consensus project that is hoping to address one of the current challenges within the 24-hour space. So what we're working on right now is a consensus on the terminology used to discuss the 24-hour day. So as I mentioned at the start of this talk, there's a number of different ways that we can refer to the 24-hour day. So there are different approaches for it, but we broadly understand that it's composed of these three behaviors of physical activity, sedentary behavior, and sleep. Sometimes it's also standing behavior. So it's not really clear whether standing behavior is a separate entity or whether it's something that is included in one of these three behaviors. In addition, the terminology that we use to discuss these behaviors is really confusing. So obviously there is something like 24-hour movement behaviors. You might have heard of movement behaviors at some point. There are now movement behavior guidelines that exist in Canada, I believe in Australia. I'm not sure if China has them. But there's a number of different countries that are now moving to this 24-hour approach to health, although they're using different terminology for it. We also have things like the 24-hour activity cycle. That's another way that we refer to this concept. There's things like time use behavior. There are physical behaviors. That's another terminology. And then there's things like the rest activity cycle and sleep-wake cycle, and the list goes on. So a couple of years ago, my colleagues and I, we wrote an editorial that was published in British Journal of Sports Medicine talking about how the terminology used to discuss the 24-hour day is really getting confusing. And it's not really clear what we should do in this regard. So with this in mind, a couple of years ago, we started a consensus project that was going to try to identify the terminology that we should be using moving forward to discuss the 24-hour day. So with this in mind, this project is the Around-the-Clock Terminology Consortium, wherein we're focused on really trying to develop this clear, concise, and consistent terminology to discuss these behaviors. Now, this is through something called a Delphi process. So the Delphi process is composed of several different steps. The first step is the systematic identification of a problem. Next, it is composed of trying to select panel members for your consensus. Then we do something called the Delphi process itself, or Delphi rounds. And then lastly, we have certain closing criteria that allow us to end and say, okay, we've achieved consensus at this point. So for the first step, what we do is we can do a systematic search of the literature to identify a problem. So I'm sorry this is a little bit small on screen. I'll explain in 1 second, just let me get another sip of water. So what this is composed of is we did a systematic review of the literature where there were over 979 articles that we reviewed inside of our scoping review. So within the scoping review, we looked at all these different articles that were looking at the 24-hour day, looking at all 3 behaviors concurrently, and understood that the 3 behaviors that were related. So obviously this is a massive undertaking. I believe that we have 60 some odd authors on the paper right now, so it's a huge project that took over a year to get done, and we're hopefully sending it out for publication in the next couple of weeks. Broadly, there were a number of different studies that were composed of this literature review, as I mentioned. Most of the research was being done in the United States, Canada, and then China, it seems like, and then also a number of other different countries. And so all these countries are listed on screen in terms of the number of papers that came from each of these countries. And we can see on this heat map that this is something that is of interest worldwide. So this is a growing research point that's not just in one country alone or one area. It's something that the whole world is starting to get more interested in. And importantly, the number of papers in the field has been growing exponentially. So when I started my PhD in 2014, there were 20 papers on this, maybe, like in the entirety of the world. So, and now, I think last year there were 200. So if you can imagine, this is something that's exponentially growing in terms of our interests in the field. So in terms of terminology, that means if we don't have consistency in terminology, this is just going to become more and more confusing over time. And so our systematic search of literature found that there were over 199 different terms used for describing the 3 behaviors. So 199 different ways that we're describing physical activity, sedentary behavior, and sleep collectively. That is incredibly confusing. So if you're, a PhD student right now and you want to write a paper on this, that means there are 199 different ways that you could refer to this. And so if you also think about this from a public health perspective, that makes it really, really, really hard. So if we're trying to tell older adults, hey, we want you to engage in better 24-hour movement behavior, and they're like, what's that? I've only heard of 24-hour activity cycle or whatever other thing that you mentioned. That's going to make things very, very, very confusing as well for the public health message. So, to put it in perspective, during the COVID-19 pandemic, there were a number of different ways that people were referring to the pandemic at the very outset. So that made it very, very difficult for public health to be able to make sure that we were all talking about the same thing and get the message out to everybody in the exact same way. And so that's something that we also have to think about as well, as how do we best promote public health as well to make sure everybody's talking about the same thing. Now the good news is that broadly there are 2 main terms that are starting to become more popular. So there's 24-hour movement behaviors and also movement behaviors. So it seems to a certain extent that the research is starting to decide on the direction that we want to go in, but it's not consistent enough at this time. So the good news also is that we've developed a really large, broad team of individuals who've worked in this. We have over 15 different countries that are involved in this study. We have data extractors from all over the world who've been helping with our literature review. We also have 12 different scientific organizations that have assisted with this project and are currently partnered with us in terms of the project itself. And then thus far we have accomplished a number of different steps, and we're currently up to the recruitment of our Delphi panel. and also beginning our actual process of the Delphi process itself. I think at this point we have 350 nominations roughly for panelists. I think we have about 60 different Delphi panelists at this time. We're still going through the process of recruiting individuals, and so it's been a slow process in that regard. So last but not least, in terms of the things that we're trying to do, is we're trying next to do the Delphi consensus, which basically involves doing a couple different things. It involves going through a survey and then trying to figure out whether people agree on the topic in question, whether they disagree, or whether there's a plurality of opinions. And over time, hopefully after discussion and after trying to get people to agree on the same thing, eventually we'll be able to terminate the study and say that we've achieved consensus, or we could potentially be in a case where nobody agrees on the terminology, and then we have a problem, and then we have to start all over. So with that said, the take-home message from today is that physical activity, sedentary behavior, and sleep are three key pillars of healthy aging that can help to promote better functional decline as we get older. And at this time, I'm just thank you again for letting me come here today and share this with you, and I'm happy to take any questions. So, thanks again.
Okay, thank you for Ryan's insightful talk. Now let's come to the Q&A session. If you have questions, please raise your hand.
老师，你能帮我翻译一下吗？想问一个问题 ，I have a question about my English is not good, so.
那个谁翻译？让这个，他是从澳大利亚翻回来的。让那个。
我想问一下，在做研究当中，他有没有去研究这个睡眠不足的，是主动睡眠不足还是被动睡眠不足？
It's just one that I ask about. Is it when you design the research, are you going to separate like is it some of the adult? Is it maybe take some medication affect the sleep quality, or maybe something else? Are you going to maybe separate the group to find out the reason why they maybe have different sleep quality?
Yeah, that's a really good question. And first, before I go any further, I apologize. I don't speak Chinese, so it's okay. I understand. I wish I did, but I'm horrible at languages. I barely speak English. So I think the best way to put it is that we do some process of trying to eliminate individuals from studies who have sleep medications in their history. We do a full medical history with these individuals. We have a questionnaire that asks them about all the different medications that they're taking. We typically also will will include as covariates sleep medication within our study, or other things that may negatively affect sleep. So it's a very good thing to think about. Yes, we do need to consider that, but there's a lot of medications that can affect sleep as well that aren't just sleep medications. There's a lot of things that people take that may negatively affect their sleep. So, but it's something that we always have to consider. Good question.
因为我是觉得，他主动去熬夜的时候和被动熬夜的时候，对大脑的活动应该是有些区别的。
说他就尝试去区分，但是他没有理清就对。
Thank you.
You're welcome. Yeah, I have the other question about this. I think the research, the second one, is it about the study design? Is it focused on the obesity adult? Is it any difference between the normal weight and obesity in the physical activity or some sleep quality?
Yeah, that's a really good question as well. So there is a difference in terms of physical activity level between individuals that are obese and individuals that aren't. I think that is pretty self-evident. In terms of sleep quality, it's possible that it could be. Definitely as people get older, it's a possibility. So one thing that obesity is associated with is associated with a greater risk of obstructive sleep apnea. So obstructive sleep apnea is excessive snoring. It's where people will wake up gasping for air because they're basically their airway is restricted and they won't be able to get enough air while they're sleeping. Interestingly enough, though, as people age, it's actually better for them to potentially be slightly obese. So there's some evidence that suggests that having greater weight may actually be protective in some ways. So I don't really know enough about whether obesity is something that's closely related to sleep and how that affects people as they age. We do typically account for BMI, but I don't know for certain on that. But it's a good question.
I have a question. Firstly, I'm a PhD student for the social science, so my question may be a little stupid. I'm curious about if a man have a different genetic, if the genetic issues can influence the man, people's sleeping schedule or their sleeping quality.
Yeah, that's a good question. That's a really good question, actually. So the short answer is yes. So genetically, there is something called chronotype, which I didn't really talk about as well. So you might have heard of this as people being an early bird, is what we would say in the West, or a night owl is what people would also say. So those are two different chronotypes, if you will. And so that means somebody that likes to wake up really early but go to bed really early as well. That would be an early bird versus a night owl, somebody that likes to stay up very, very late and then go to bed very late, but then also wake up extremely late as well. Those are differences in terms of somebody's underlying chronobiology. There's also differences as well that exist between men and women in terms of sleep. So generally speaking, males have shorter sleep duration than females. Females need actually more sleep than men do, which is interestingly enough. But females are also more likely to experience poor sleep quality, specifically in terms of reporting worse sleep than males. Now there's a number of different reasons for why that may be. It may be biology, it could also be things like caregiver burdens. So women typically obviously are more likely to be doing things like child care, can also be family care, like the elderly or something like that in the home. But there are differences that seem to exist between males and females in terms of their underlying sleep, and also genetics may play a role as well. So that's a very good question.
Thank you.
Yep.
I have a question about your first research is about you have a bright light syrup. So could you please explain why you choose this kind of syrup? Do you have any rationale for that?
For like a questionnaire for bright light?
Why you choose this kind of syrup?
Oh, okay. Why we choose bright light therapy?
Yes.
Yeah, so light is actually the most important thing in terms of what organizes our circadian rhythm. So let me put it, here's an easy way to put it, is if we were to stay up all night, okay, and we stay all the night through and we stay awake, and all of a sudden it's light out during the next day after you stayed awake all night, that is partially because with light, it actually causes your biology to not allow you to fall asleep during that time because there's light. It will actually do something called phase delay your ability to fall asleep. So meaning it will push back the time when you need to actually sleep again. Even if you're really tired, it's going to be almost impossible for you to fall asleep because it's very, very bright. It's the same thing for jet lag as well. So if you, like for me, for instance, I flew here from Vancouver, so it is 15 hours behind right now. So regardless of what I wanted to do, like last night I didn't go to sleep until after midnight. I still woke up at 6:30 in the morning because for me that's still my circadian rhythm is off. There's a disconnect in terms of when I want to be sleeping versus when I'm able to sleep. And over time, it starts to adjust because light, my time awake during the course of the day, is going to start to entrain my circadian rhythm at the proper time. So that's why light is what we consider to be the most important thing in terms of our circadian rhythm itself. Now there's also other things that I would point out, is even though we do know that light's the most important factor for our circadian rhythm, we actually don't really know whether it's useful in terms of the intervention itself and how we would actually best do it. So does it matter about the intensity of light? There's debates about whether it should be white light versus blue light versus any light. Is that really going to be beneficial? How long you should be doing the light therapy for? At what distance somebody should be doing light therapy? So the light box that we use, it's a little box, maybe like less than the size of my computer, and somebody was supposed to sit in front of it for an hour, once in the morning and once in the evening at specific times, and then that would allow them to hopefully to help to improve their circadian rhythm. But we don't know what the distance is supposed to be, so it doesn't matter if I'm like, a meter away, or do I need to be 10 centimeters from the box and staring directly into it for an hour in order for it to actually work. We don't know the answer to that. So it's an interesting area, but we're not really sure how we can best use this for a therapeutic purpose and how to do it individually, if that makes sense. Any questions?
Questions. I think during the last decade, there are so many papers published around this topic. Do you guys have any public acceptable database for cooperation or analyze?
Yeah, that's a really good question. So the data that we have data on the actual papers themselves, but it's very limited. So we have the 970, we have a database that's available. It's an Excel data sheet. I'm open to collaboration, on reasonable requests. I would need to check in terms of how that would work from a cross university standpoint, because our university, I think that we might need to sign paperwork or something like that, but we're open to it. Now the one caveat that I would mention is that our database is relatively limited, so we have name, author, demographics and things of that nature, but it's not like we have details of the actual study design itself. That may be something that you would need to look at in more detail, but we are open to it under reasonable requests.
Talking about the so-called light therapy, do you have any dark therapy? Because Macau is a gambling city. People are doing the job in the casino all night long.
Yeah.
Whenever they go back home, they need a dark environment to sleep.
Right.
Do you have conduct any experiment about this?
No. We actually haven't looked at specifically in a place like Macau, which I think is very
Las Vegas.
Yeah. We do. So one thing that we do have is we haven't done it personally, but there's a lot of evidence looking at shift workers. So not the same thing as somebody working in a casino, but shift workers, emergency responders, firefighters, paramedics, people that work like late evenings and things like that. There's a lot of evidence that shows that these types of jobs are associated with all sorts of sleep problems. And so I think in Canada, I don't know whether it's the same in Macau, but in Canada there's actually been a lot of changes that have occurred in terms of when we allow, or how long we allow people to work shifts. So before it used to be 72 hours that people would work shift, and then we've actually scaled it back to, I believe it's like a 2-week window. So it's 2 weeks on followed by 2 weeks off. And so the idea behind that is because it's going to take time for your body to shift back to the normal circadian rhythm, and then you can have time to shift to that nighttime rhythm. Even though it's really, really hard and it does horrible things to your body over time, but it's something that those individuals have to do as well. So there's not really a perfect solution to it. But I'd be interested in something like that. That would be an interesting topic.
Thank you.
Yeah, of course.
Just one small question. I noticed that you use the MRI machine to detect the human brain situation, right? But according to my knowledge, MRI could do more than just certain brain. It could also detect the other in that defects, such as the human organs. Do you use the other defects as well, like the liver or kidney situation, because it could also present the sports or the sleeping sleeping qualities.
Yeah, so we don't look at those areas because that would be, so a MRI scan that we are doing is a research grade scan. It's quite intensive. So from our standpoint, you can't really look at everything. And we also work in a lab that's primarily focused on cognitive health more than anything else. Now that said, you are right. Like we could definitely look at other areas. And to a certain extent, we can and we do with what I was telling you about earlier today with dual X-ray absorbometry, so or DEXA. So DEXA is an opportunity that we do have as well. But like, do I personally look at anything with those areas? No, but like, I think that's something that like you could do, absolutely. I don't know if it's something that we will do, but I think it's an interesting idea. Like maybe we could definitely look into it more. But I think there's definitely people that, there's lots of people that look at how sleep can be affected by, or can affect liver function, you know, gut health, and things of that nature. There's a number of different resources out there. Yes?
I noticed in one study, the accelerometer was chosen to be monitoring the physical activities, looking at something. I'm curious, why do you choose that graph, not active graph?
Yeah, that's a great question. So the thought process at the time, I actually wasn't, so this was done during my PhD, so several years ago. The postdoc who was running the study at the time was convinced that that specific actigraph, the motion watch, was the best accelerometer to use for being able to measure sleep. So actigraph at the time, in roughly 2014, did not measure sleep. It only measured physical activity at that time. So what we actually did over the course of several years is we used the motion watch, and we developed it into a way that we could actually measure physical activity as well. So we calibrated to be able to measure physical activity and also sedentary behavior at the same time. So that's why we chose that monitor. Now what we are doing is we have switched over to the actigraph because we do think that at this point in time, given the fact that you can measure physical activity, sedentary behavior, and sleep with the actigraph, they've managed to figure out that issue. Is it seems like it's a lot more reasonable to use that over the motion watch, and we've switched in that direction. But at the time, it's what was available to us. So, no problem.
Please.
Is there
Last question.
Okay.
is there any control over the physical activity of the subjects the day before the cognitive test?
Yeah, that's interesting. So there's not, broadly speaking. So there's differing opinions about physical activity and its acute effects on cognition. So there's some evidence suggesting that somebody that's physically active one day before performing cognitive tests can actually improve their cognition, but acute effects of physical activity are at most modest. They're probably very, very small. Now, one thing that we do is typically we account for baseline physical activity levels through some measure, using something like a scale, like the pace scale for the elderly or something along those lines. But in terms of measuring physical activity and or trying to control for it, it's very hard to do unless we keep them in a room locked up somewhere and we don't allow them to get any exercise, which is very rare unless you're doing bed rest. So.
Okay, we come to the end of today's symposium. Finally, I'd like to express my sincere thanks to Brian and all attendees for your active participation. Okay.